This last video is going to be all about imaginary numbers. Imaginary numbers are used a lot in electricity and technology. We could not have the technology we had today if somebody didn't figure out how to work with imaginary numbers. Imaginary numbers are necessary because they can get you back into a real number system. But imaginary, by definition, is the square root of a negative number. So the square root of -1 is imaginary. And if you never leave imaginary with a exponent higher than 1. It can always be simplified. So we're always looking for the I with a power of 1. If it was a power of 2, that'd be the square root of -1 times the square root of -1, which is just -1. If it was cubed, it'd be -I. If it was to the 4th, it's I squared times I squared, and -1 times -1 is +1. And then if I keep going, I to the 5th, well, that's I to the 4th times I, so that's just 1 times I, so it's just I again. I to the 6th, I to the 4th times I squared, so that's 1 times -1. We're back at -1. So these 4 just start repeating and repeating and repeating and repeating. So if you get I to the 23rd, then that is 4 I to the 4th 5 times, right? 4, 8, 12, 16, 20. So the 20 exponent of 20, and then we have I cubed. So when I see I to some power being higher than it needs to be, I'll write I to the highest multiple of 4 that goes into that exponent times I to whatever is left over. It'll always be under 4 if you got the highest exponent of I, the highest multiple of 4 that goes into 23. I to any multiple of 4 is 1. And then the others you'll have to memorize. -1, -I. So this is 1. This is -I. So here your answer would be -I. And it keeps going. All right. If you're just trying to simplify a radical with a negative, a square root with a negative, the square root of -1 is imaginary. That's the definition of imaginary. So you're just going to pull that -1 out of your square root and make that your I. Make sure it never gets underneath your radical. You can put it in front, but imaginary should always go last. The only reason people don't put it last is because if you accidentally put it underneath the square root, then this is saying the square root of -1, and we will never use that. So if the I goes under, it's wrong. So that's why sometimes people put it in front. And then you have to still break down your square root of 18. So the square root of 18 is 2 times 9, which is 3 times 3. And then you break that down like normal. So it's 3. Some people put the I here. I always put it last, just to make sure it's not under your radical. I get laughed at for putting that tail because it's not actually there. I just know if that I goes under, I'm wrong. So I like to make sure that my teacher knows that I is outside. But you technically don't close a radical, so it does look a little funny. A negative underneath the square root is imaginary. So I'm going to take the negative out and make that my I outside my radical. And then with fractions, don't be scared of them. You just take the square root of the top and the square root of the bottom. The square root of 49 is 7. The square root of 4 is 2. And then don't put the I on the bottom. It can go on the side or with the 7. Either of those are right. But do put it after the real number. Real before imaginary. The 3 square root negative under the radical becomes under the square root becomes the I outside my radical. And then we break down 50, which is 2 times 25, and 25 is 5 times 5. So -15 square root 2, I on the outside. Okay. Now, if you're working with it, I in an expression, it's treated just like a X. The only thing is you can't leave I higher than 1. So if we're just adding these, which is what we're doing, you just add the real numbers together and add the imaginary together. So my real number is 6 plus 3 is 9. -2i plus 14i is 12i. Again, standard form for imaginary is real before imaginary. If you put your imaginary first, I will take off a point, so be careful. Real before imaginary. Subtracting is the same, but I like to distribute my negatives so I don't forget that I'm not doing negative 3i plus 7i. So this is distributing a negative 1. So that's negative 1/4 minus 7i. So then when I go to combine them, I'm not thinking I'm adding, I am subtracting them. So I already distributed my negative, so now I just combined my real terms and my imaginary. 3/4 minus 1/4 is 2/4, and 2/4 is just 1/2. Negative 3i minus 7i is negative 10i. So 1/2 negative 10i. Here I'm just multiplying all of them, so I'm going to put in the calculator negative 5 times 1/2 times 6. Well, when you're multiplying numbers, it doesn't matter the order you multiply them. So I like to do 6 times 1/2 is 3. And then 3 times negative 5 is negative 15. And then how many i's do I have? I have 1 here, 1 here. That's 1, 2. Here's 2, so 4. I to the 4th. And then we can't leave I with an exponent higher than 1. So I to the 4th is just 1. So that's negative 15 times 1. So that's just negative 15. Just like we broke down this one up here. Just to show you, like if you had I to the 13th, I'm just making something up. This example, 39.5, I don't know, just to show another I to the 13th. The highest power of 4 that goes into this one is 12. Multiple, not power. Multiple of 4 that goes into 13 is 12. With 1 I left over, I to the 12th would be 1 times I would just be I. Just to practice one last time. All right. Distribute. We're still multiplying, but when you multiply two terms, a binomial times a binomial, you're going to end up with 4 terms that can be simplified. So the 4 has to be multiplied to both of them. So 16 plus 20i. And the negative 5i has to multiply to both of them. Negative 20i minus 25i. I times I, just like with x's, is I squared. Two middle terms, one's 20i, one's negative 20i. They cancel out. I squared is negative 1. You can't leave I with any power higher than 1. So this is just 16 plus 25, which is 41. If you notice, these are complex conjugates of each other. One's negative, one's positive. One term's positive, negative, positive, positive, negative, positive. You change the sign of the middle term, and that way it will always cancel out and get you back to the real number system. So that's how that works. If it's squared, you're multiplying the same thing to itself. So the 4 has to get distributed in. 16 minus, that's a 4i. I don't know how to make that work. That worked. And then the negative I is going to both. So negative 4i minus I squared. Negative times a negative is a positive. Don't get too quick to cancel things out immediately. 2 negatives make a bigger negative. And then I squared is negative 1. So I'll replace that. So real terms, 16 minus 1 is 15. Real numbers before your imaginary. Okay. Oh, just throw in some radicals. Make you remember your radical stuff. 6 has to get multiplied to both. 6 times 6 is 36. 6 times 2, square root of 2i. The 6 and the 2 can't multiply because the 6 outside the radical. The 2's inside. And I goes last. Inside, these are complex conjugates, so we should get back to the real number system. Is negative 6 square root 2i outside the radical. And then lastly, negative, the 2's are both under the radical, so they multiply I squared. What I like about videos is if I'm talking too fast, you can slow me down. If I'm talking too slow, you can speed me up, right? Square root of 4 is 2. I can't leave I higher than exponent of 1, so that's I squared is negative 1. Negative 2 times negative 1 is positive 2. 36 plus 2 is 38. Final answer. All right, the bottom are all divisions with imaginary. If it is just one term, you can just multiply I to the top and bottom. If it is a binomial, 2 terms on the bottom, then you have to multiply by the complex conjugate plus 2i. And you just change the sign of the middle term plus 2i. So since it was a negative 8, it stays a negative 8. Okay. Some people ask why I can't multiply by negative 2i on top and bottom. And you can, you're just going to be simplifying more, right? I squared is negative 1, which is what we're looking for. We're trying to get I out of the denominator. Just like you can't leave square roots in the bottom, you can't leave imaginary numbers in the bottom. So this is 2i over negative 2 times negative 1. So that's just 2i over 2. And then the 2 and the 2 is 1, so it's just I. You know, you can reduce that here too. 2 over 2 is 1 over negative I. That's interesting to see. So I over negative I squared, and negative I squared is negative 1. There's a lot of different ways to do this. I don't know why I'm doing it another way, but that's just 1. So we're back to I. Again, I didn't mean to. I just realized I could simplify earlier. Interesting. Just kind of like this one. I could simplify by 2 in all these. I'm going to have to do it at least at the end. But if you want to do it at the beginning, you can. 2i. This is weird because I'm distributing backwards. 2i plus 8i squared. I can't leave that in my answer. I have to simplify that. 10i squared. We're trying to get the I at the bottom, so I'll have to simplify that 2 as well. I mean, not 2. I squared is negative 1. So I'm replacing all those with negative 1s. Okay, and then I have to simplify all these, but I'm going to put the real numbers first. So negative 8 over positive 2i over negative 10. And then they're all even, so I'm going to divide all of those by 2. So I now get negative 4 plus I over negative 5. If you did happen to scan your answer through like Mathways or Photomath or something like that, sometimes they rearrange the negative. So they don't like to see like a negative at the beginning or a negative over a negative. So sometimes they'll change all their negatives around. So negative 4 times negative 1 is positive 4. I times negative 1 is negative I. Negative 5 times negative 1 is positive 5. This is the same answer. So I'd accept either of those. I don't see why you do that if they're the same, but sometimes they do it so that it doesn't look like these negatives would cancel out. Because they don't cancel out, you'd have to multiply everything by negative 1. Not my favorite, but at least it's a good way to check your answer with Photomath, Math Apps, Mathways, Math Papa. Yep, I know them all. No, actually, there's more, but I'm not going to start giving you the names. Distribute, right? FOIL is the one acronym for it. First, outside, inside, last, whatever you want to call it. 8 times 8 is 64. 8 times 2 is 16i. 6 times 8 is negative 48i. 6 times 2 is 12i squared. That's top. Bottom. Positive 64. Negative 16i. Positive 16i. And negative 4i squared. I did in order if you need to go back and look at that. Those two together, and then the last two together. The first 8 to both 2, and then 6i to both 2. Simplifying. Simplify the top. We have negative 64. My i's combined to get me negative 32i. This is a lot of talking. Plus 12. Don't leave I squared. That's just negative 1. Middle terms cancel on the bottom. Minus 4 I squared is negative 1 again. Simplify this. So this will be minus 12, and this will be plus 4. So negative 64 minus 12 will be negative 76 minus 32i over 64 plus 4 is 68. Now they're all divisible by 2. So I'm going to drop it down by 2. And then you'll see they're actually all divisible by 4, or 2 again. So if you did it by 2 the first time, you get negative 38 minus 16 8i over 34. And then they're still all even, so you have to do it again. 19 minus 8i all over 17. There you go. There's your final answer. I hope this helps.